All right, welcome everyone. Our first prep video for the semester here. So for today, as promised, we're going to start with equations of lines. So our first learning outcome here. And ultimately, by the end of this lesson, what are we going to be able to do? We're going to be able to find the equation of a line with a few different types of scenarios. Maybe we're given 2 points that sit on the line. Or maybe we're given 1 point and some kind of description about the slope, some more information about the slope. And we have a few important equations that we're going to start to look at. So we have a slope formula that tells us how to calculate the slope of a line. And for this formula, we need 2 pieces of information. We need 2 points that we know sit on our line. So for our slope formula, we need 2 points. And in the notation here, point 1, we could call that x1 comma y1, and point 2 is x2 comma y2. And when we, so we have our 2 points. And the only thing we have to be careful of when we use this formula is we just have to make sure when we plug the coordinates in that we match them up. So in our formula here, x1, y1 have to match up in our fraction, and x2, y2 have to match up in our fraction. So the slope formula is the difference of our y-coordinates. So it's the y-coordinate from point 2 minus the y-coordinate from point 1. So that's our numerator. And the denominator is the difference of the x-coordinates. So it's the x-coordinate from point 2 minus the x-coordinate from point 1. So the slope formula, and we'll be looking at this in class, you could really think of this as the change in y over the change in x as you go from one point to the other. All right, so that's one of our important formulas. That tells us how to find the slope m. Now, how to actually get the equation of a line, there's kind of 2 different versions that we might use. So the first one, and probably the one we'll use more often, is called the point slope formula. So this gives us, we need 2 things in order to use this formula. We need to know a point, kind of like the name suggests. We need to know a point. So x-coordinate, y-coordinate. And we need to know the slope, which we usually use as m. So we need those 2 things. And when we plug these in, we've got our x-coordinate, which we would plug in right there. We've got our y-coordinate, which we would fill in right there. And then we have our slope, which goes in front of all the x's. And when we use this formula, the y here and the x here, these stay as variables. So the y-coordinate, the slope, and the x-coordinate, those are all going to be numbers. And the x and the y, those are going to be variables. So it's important to kind of remember that. Variable and variable. Okay, so this is our point slope formula. So it's y minus the y-coordinate is equal to the slope m times x minus the x-coordinate. And a way to kind of remember this formula is if you were to take all this x stuff and divide by it, divide both sides of this equation by all this x stuff, you would have x minus the x-coordinate over here, and that kind of looks like our slope. All right, so this is one equation, one way to get the equation of a line. Another way is with what we call the slope-intercept form. And this is kind of the nicer version. And essentially, we're taking this equation and we're solving for y. So that's all we're doing. So this is just another way, an alternative way to write essentially the same information. Now for this one, the implication of these constants m is the constant, and b here is where the line crosses the y-axis. So in this formula, we need to know the y-intercept. And that's what the b value is. So this tells us high up along the y-axis where our line crosses the y-axis. And then our slope is m again. And in the formula, the y here and the x here, those are just variables, just like before. All right, so these are going to be the three main formula we use. So let's try an example. So let's find the slope and the y-intercept for this line. So right now, the equation that we have here, 2x plus 3y equal to 6, is not really in either of those two forms. So it's really not written in point-slope form, and it's not in slope-intercept form. So we're going to have to do a little bit of work to get it into one of those two forms. And let's get it into slope-intercept form. So essentially what we're going to do is we're going to solve this equation for y. All right, so how are we going to do that? Well, we want to look through our equation, and anything that doesn't have a y in it, we want to move to the other side. So this one has a y in it, so we want to keep it where it is. This doesn't have a y, the 6, but it's already on the other side of the equal sign, so that's good where it is. We got to do something about this 2x. So we're going to move the 2x. And the way we do that is with subtraction. So we're going to subtract 2x from both sides. So we get 3y is equal to 6 minus 2x. All right, so that's pretty good. We're getting y all by itself, but we're not quite done because we want just y over there. So we got to do something about that 3. And right now it's 3 times y. So the way we kind of undo the multiplication is we're going to divide both sides by 3. Okay. And when we do that, well, we get y is equal to 6 minus 2x all over 3. All right, so this is starting to look better. We've got y all by itself, but now we want to start to think about what is that. We want to find the slope and we want to find the y-intercept. So we want to go back to our equations. And we're going to the slope-intercept form because that's what the information that we want. So we want to make it look like this. Y is equal to mx plus b. All right, so that's our form. That's what we want to get it to. So we want it as y equals mx plus b. So, well, right now we have this big fraction. Well, a property with fractions is rather than dividing the entire numerator by 3, we can break it up. And we can divide the 6 by 3, and then we can divide this negative 2x by 3. So we can make this into two separate fractions. So we get y is equal to 6 over 3 minus 2x over 3. And just to make it kind of look nice, in our form here, we see that the x term comes first. So let's just move these terms around a little bit. And while we're at it, simplify the numbers that we can. So that's 6 divided by 3, that's 2. So if we do our little bit of rearranging, we'll put the negative 2 over 3x first, and then we have our plus 6 over 3, which is just plus 2. So we're just moving things around. And now, this is good. We can match things up. So, m, the slope, is the number in front of the x, and our y-intercept is the number that's all by itself. So we just kind of match things up. So now we can see slope m is equal to negative 2/3, and y-intercept b is equal to 2. Okay. And if we wanted to, we could also write, so this y-intercept, if we wanted to write this as a point, the x-coordinate would be 0, and the y-coordinate for the point would be 2. So that's the specific point on the xy plane where it crosses the y-axis. All right, so let's try one more example, and I'm going to save this one for class. We'll work on this one in class. But let's try the other formula that we haven't done. So, well, one of the other ones. So we want to find the slope of the line passing through these 2 points. All right, so for this, we're going to use our slope formula. So the slope is the change in y, so it's the subtraction of our 2 y coordinates divided by the difference of our 2 x coordinates. So it's change in y over change in x. And when we do this, it really doesn't matter which point we pick first. So you'll get the same answer regardless. You just have to be consistent. So I'm going to make this one, just because it's written first, I'm going to call this one point 1. And then I'm going to call the other one, well, it's written second, so I'm going to call that one point 2. All right. So when we fill these coordinates in, I'm going to take the y-coordinate and the x-coordinate from point 2, put those first. And then I'll take the y-coordinate and the x-coordinate from the other point and put those second. And you just got to be careful. Make sure that these match up, that they're coming from the same point. All right, so let's calculate our slope. So m, so what's the y-coordinate from point 2? So the y-coordinate from point 2 is that second coordinate. So it's the y-coordinate, and then this is our x-coordinate. So the y-coordinate is 4. And then the y-coordinate from my first point is negative 2. So I'm going to have 4 minus negative 2. And then I do the same thing in the denominator, but now I'm doing it for the x-coordinates. So I take the x-coordinate from point 2, which is 9, and then I'm subtracting the x-coordinate from point 1, which is 6. And again, the thing to be careful of when you're doing this point slope, or the slope formula here, you just got to make sure that the values you're using are all coming from the same point. So the 4 and the 9 are coming from point 2. They kind of match up. And then the negative 2 and the 6 are coming from the other point. So we have the order correct. And then if we simplify, what do we get? Well, on the top, we get 4, and then this double negative becomes positive. So we end up with 4 plus 2, which is 6. And then in the denominator, we get 9 minus 6, which is 3. And that simplifies to 2. So our slope here is 2. All right, so a little bit of practice there. So in class, we're going to try a few more of these type examples, see how to maybe draw some lines as well. So we'll see you then. Bye-bye.